Hi everyone, I am Kavishkar from the team Hertz Labs, and I am going to present our second year analog design project done in the semester, which is the 5 band equalizer. So the 5 band equalizer, as the name suggests, this equipment can control the gains of individual bands of audio source. So this equipment can adjust the gains of these bands, which are 20 to 300 hertz, 300 to 1 kilohertz, 1 kilohertz to 4 kilohertz, 4 kilohertz to 10 kilohertz, and 10 kilohertz to 20 kilohertz. We can individually adjust the gains of these audio bands. So going front, this is our circuit diagram, a part of our circuit diagram. We are using an 18 volt single power supply designed to power up our application because the dual power supplies are generally not used in day-to-day life, and this is the part which supplies the power from the single supply design to power up these dual supply op amps. And here we have the input stage, which buffers and converts this into a mid voltage, the signal into a mid voltage, and then single pass band filter. So this is a circuit of our single filter, which is a Shalansky filter, and two of these filters are cascaded to form a single band. And we have used this transfer function to analyze our filters, and the results are shown here. That means we have precisely calculated the mid frequencies, the gains of these filters, and the bandwidths of these filters. So coming up next, we have the response of the first band, and as you can see in this log scale, it has a somewhat nice bandwidth and a steep roll off. So there's a sharp filtering effect in the required band. The 300 to 1000 range, 1 kilohertz to 4 kilohertz range. Then we have the 4 kilohertz to 10 kilohertz range. Maybe you can see the screen is a bit less intensive, and then 10 kilohertz to 20 kilohertz range. So this is our overall filter response, and as you can see, there's a minimal distortion for the overall response when we are considering the zero gain in decibels instance. And yes, we have used the op amp TL072 op amp, considering the noise requirements of our audio processing and the slew rates and power consumptions. Based on those factors, we have opted out the TL072 op amp. And also it's a dual op amp package, so that we can implement a single filter using a single op amp, although it has two filter stages in cascade. So regarding the enclosure design, we have tried to make this look minimalistic, and also it gives a bit kind of a 60s vibe with this wooden outer frame and the audio level indicators and the jacks, the audio input and output, the standard jacks we have used, and the power supply port is here, and we can control the gain, the overall gain of these filters. Then individual individual band responses can be adjusted as we intend to, and yes, it works perfectly, and there's a good selectivity in each of these bands. We will see that in a few minutes. So yeah, we have our logo printed out here. Yes, the PCB design. The PCB design was done to minimize the noise effects from the background, and also we have tried to replicate each filter band in the same way, so that it has a pleasing look, and also avoids the distortions that can happen with varying degrees, that is minimized by implementing these filters in the same way. So yes, this is our PCB unit, which filters out the bands, then adds those bands together. And next, yes, the schematics. Then the display circuit is driven by a separate PCB, and the audio controlling part, that means controlling the gains of individual bands, is done in the other PCB using variable resistors. Yeah, the power calculations. So we have used 18-volt power supply, a single power supply for this design, and then the input source current. It just consumes 0.027 amperes, which ultimately gives a power consumption of 485 millivolts, which is I think negligible when we look at the power. The input current for op amps is 940 microamperes, a minute amount, and the typical input signal power can be 150 milliwatts. So that's a bit technical details about our product, and then here comes the cool part, which is the demonstration of our product. So let's move on to that. I'll connect this into the power supplies. We are still using the power supplies part of this equipment. We are intending to use a separate 18-volt power supply or a 24-volt power supply, and regulate it to 18 volts to power this up. So let me fix this to the power supplies. With that, we have come to the end of our presentation. We are Team Hertz Labs from the University of Moratuwa at the Department of Electronics and Telecommunication Engineering. Thank you everyone.